house in taking your money without permission.
Do we just wait just a sec?
Oh my gosh.
And then
You got a minimum.
as long as you are here.
I'm just gonna leave you there. Are you?
Yeah.
You're on right now, right?
Yep.
Okay.
We just like color the parts. So this should be blue. Right here. And then this is white.
So this is supposed to be white.
Yeah, but that's okay. So then you're good, yellow, yellow, yellow. So just wherever you see dots in this, put it that color that's at the top.
Okay, if you're just on the coloring part, that's okay. We're gonna have a quick 10-minute conversation, and then you're gonna be able to answer some of these questions. Now, the questions that are on analysis.
And it's like, what is it?
That's how you're great.
So, when you made your graph, what we should call it? You made your graph yesterday? Did it sort of follow this pattern? A little bit, not perfectly, right? Why would it be hard? So now we're gonna close our combos a little bit, and then I need everybody to be turned somehow this way. What would we have to do in order to make our graph look like this yesterday? How many cards did I give you? There were like 100, okay? Were there about 100 stars in the universe? No. So what would I have had to do to the cards? 4. I would have had to give you a lot more. If we were gonna make a really, really close representation, what you probably had was, you probably had like 2 here that were like, you probably had 4 or 5 red ones that were sort of off on its own. And then you should have probably had this like sort of line. It was kind of look like that. Solid, okay? If we're in math class, what do we call these? Yeah, outliers. Okay? They don't usually fit the pattern. They're sort of a pattern, but some of them don't. So we would call those outliers. All the stars that fit on that pattern, okay, we call them a certain group of stars, and I made you look up the definition of that. Who knows what that was? If it fits the main pattern, what do we call that? Say louder. The main sequence, okay? Edward, you want to turn around? So I'll see. That's okay. We're still going to come. You can sit. We'll talk. Okay? But it generally fits that pattern. So here's a couple things, right? This is what they normally use, right? Scientists and researchers and astronomers, they use this HR diagram. It stands for Hertzsprung-Russell, which is the last name of 2 dudes who got all the credit for this, okay? And I'm saying those are the dudes who got all the credit for this. There was somebody that had a big part of this, but didn't get a bunch of credit. Do you want to guess anything about who this person was? Is a woman, right? So we're gonna, at the beginning of class tomorrow, we're gonna watch just a 3-minute blurb. Not that you need to know about her, but in class we're gonna say, hey, this is another person who, just like we did with Henrietta Lovett Swan, like she got no credit and she beat shit. Right, that seems to be the trend. And we're gonna sort of talk about some of those in almost every single unit, just because we can, and we're gonna give them some credit, okay? Here's a bunch of stuff that we can know. And a lot of people have asked me this unit, how do we know, like, if there's something that's 100 light years away, and we can never go there, and we can't set a satellite there and get information about it, how are we possibly knowing it? This is telling us a bunch of stuff. So I can look and figure out where a star is, like here's our sun, right? Here's a bunch of other stars. I can look at this one or find something that's far away. I know the brightness, the distance, the temperature, how long that it should live, what it's using on the inside, and what exactly is going on, what stage of its life it is, just by looking and figuring out its place on this diagram. Okay? So if you look at yours, really the conversation that we're going to be having is about this front table. So I want you, even though some of you guys are working on the back, I want you to flip to the front because we're going to have conversations about these right here. We just need to start making some relationships between things and putting things together, right? So when I go from, and here's something that I'm going to point out, because if you go to the bathroom and you're washing your hands, okay, and you turn on the red dial, what's the temperature of water that's you're gonna get? It's gonna be hot, right? And if you turn the blue one, what temperature is that water gonna be? It's gonna be cold. That is the exact opposite of what we have here. Okay? Which one is the hottest star, the blue or the red? The blue. So as I go from blue to light blue to white to yellow to orange to red, and if you look down your sheet, you should see this range of temperatures. So you should see this making sense. When I go from dark blue and I go down towards red, what happens to my numbers for temperature? They go down. Okay, so when I go from these blue stars to these red stars, so when I go from the top all the way down, and I'm going left to right, it's getting cooler. Now, it's not getting cold, right? The red ones have a surface temperature of what? Some of them are like 2,000 degrees Kelvin. That's not cold. That is hot. So we still can't go hang out on these stars. Right? I know. I was thinking about just getting a picture of Beyonce and putting her line right here. She's able to do the star. Okay. I love Beyonce. I think I'd cry if I saw Beyonce. And it'd be a not breathing cry, because it'd be like this. And then it just, I don't know.
Oh my God.
That's what would happen. It'd be very sad. Okay, so when that happens, temperature's going down. What else is changing when it goes from blue to red?
It lives longer.
What happens? What else goes down? Right. The brightness also goes down. So this is things that 9:30 is already got. When I say what's the relationship between temperature and brightness, they don't know what to say. When I say what's the relationship between these two variables, what? Brightness is like if this happens to this variable, this happens to the other one. Okay? So if something happens to temperature, this happens to brightness. Somebody tell me what that is. What's the relationship between temperature and brightness? You just told me. If temperature goes down, brightness goes down. Okay? If brightness goes up, what happens to temperature? That's the relationship between the two of them. Okay? Now look at lifetime though. So tell me what happens when I go from blue to red in terms of how long the star is going to live. So that's the third column. Take a look at it. And I know it's confusing because it says like 10 to the whatever.
I looked that one all the way up to that one. That one's not long.
Okay. What happens to lifetime? How long the star is going to live? You should be looking at your sheets on the front right now, third column. Okay. What happens?
They live longer.
They live longer. When I go from blue to red, which one's going to live longer, blue or red?
Red.
Red is. You have any idea why this might happen?
Because there's not much heat in temperature.
There's not as much heat, right? So think about it this way. How many of you guys have ever seen a track meet? Or gone to a track meet? Or had to run in gym? Or had to run in a sport, okay? If I said, you're going to go out and you're going to run from this end of the football field to the other end as fast as you possibly can, right? And then I said, all right, JC, you're going to run 100 meters as fast as you possibly can. You're going to go out, and I just want you to jog. Don't stop until you're tired. Who would end up being exhausted first? Probably JC, right? Because you ever seen those, like, sprinters run? Their faces are like, and they're super strained. I had a friend who just randomly, he ran cross country in college and then randomly was like, I think I'm going to start running marathons. And then his first marathon qualified for the U.S. Olympic trials. Wow. Yeah. he just did it again. He ran a marathon. Guess what his time was?
9,000.
2 hours and 18 minutes.
Wow.
26.2 miles. And in every picture of him in the marathon, he's smiling. He does not have a straight face. He's also like 5'6" and looks like Niall from One Direction. He's a math teacher. He's the head track coach at a school in Wisconsin. And every time I see pictures of him on Facebook, I'm like, oh, that's him. I think it's just all his high school kids. But he never he's running these marathons. Not joking. He runs these marathons and doesn't run out of energy, right? He's also not, but if I said, I want you to sprint, run as fast as you possibly can, he'd run out of energy way quicker. So if we're trying to figure out why certain stars live longer, what can you assume about how fast they're burning their energy? If a red star is going to live longer, how quickly do you think it's going through nuclear fusion and burning through that energy?
Very.
It's not gonna burn that energy that fast. Okay, which means that it's gonna be able to have a longer life as a star. Okay?
How many years will our sun live?
Our sun is about halfway through its life. And I think they've estimated that it'll last about 10 billion years. So we're about 5 billion years through. So it's going through a midlife crisis right now. At my mom. I think I went through my first life crisis at 19. When I realized I slept through all of these classes. How am I supposed to take a test tomorrow? So that was the first time I drank several cups of coffee. And I stayed up all night. And I basically read 4 chapters and taught myself a month's worth of stuff. And that's when I realized, crap, I'm a really bad student. So when I'm looking on this one in the back, okay, I made you look at 4 red stars, right? When you flip on the back, I made you look at 4 red stars. What was about the same as for all of them? Their temperature was about the same. They were all right around 3,000 degrees Kelvin. Now, some of you guys might have gotten 4 that had really tiny brightness. Did anybody find some that had a big brightness? It was 900 suns or 320 suns, 9,000, 480, okay? So their brightness is very, very different. And I wanted you to make assumptions. What do you think about the size of the star for the ones that are very, very dim? They're 0.00006. They're probably tiny, right? Do you think that they'll last a long time? Do you think they'll have a long life? Yeah, right? What about the ones that have a huge brightness? What do you think about the size of those?
They're going to go boom.
They're probably very large, and how long do you think that they will, that their lifetimes will be?
1 day. Short.
If it's a very, very large star, do we think it's going to live a long time or a little bit? A long time. Right, so a great question would be, I found this new star, right? It's really hot. Is it gonna have a long lifetime or a short lifetime? What would you say? It's really hot. So where would it go longer? There's a good chance it's a blue star, right? And it's very, very bright. Bright stars, do they last a long time or a little bit? They have long lifetimes. Hey, you guys need to focus. Put your stuff down. Pay attention. Okay? This also helps us determine what's going to happen at the end of their lives. So I'm able to look at certain stars and say, oh, it's on this spot. That's going to become a black hole, or that's going to become a white dwarf, or that's going to become a neutron star. It all depends on where it lies on this diagram. Okay? Really, really big ones, they have a huge mass, which means that when they start to die, they're probably going to have one of those huge explosions called a supernova, and they're going to have a black hole. Okay? These are all going to tie together. So I'm going to be able to say, this is a very dim star. That's going to tell you about the temperature. That's also going to tell you about the lifetime, and that's going to tell you about what is going to happen when it dies. You will be asked questions like that next week on our test. where I didn't specifically teach you that, you have to tie 2 or 3 things together, okay? So what we're gonna do now is there's some questions that are on Canvas. There's 5 questions that are on Canvas. You are to do these individually. However, I'm gonna let you use this sheet, which should make it super easy, all right? And I'm gonna ask that you do a favor. So when you get on Canvas, there's 5 questions. You're gonna have to copy and paste them. Starting to lose focus. You're gonna have to copy and paste them into your text box. You're not gonna lose any points if you don't do this, but it would help you tremendously if you change the color of your answers so that I can see them easier. Okay? So when you type your answer, if you could make it a different color than the question, it makes it just quicker for me to grade. All right? Please use your handout. All right? Use your handout. It's gonna make things super easy. And then I'm gonna come around and help you with some stuff. Tomorrow we're gonna look specifically at life cycles and stuff, and we'll start getting into some black hole stuff. Okay. If you still need colored pencils, they're up here. Okay. Yeah, that's fine. I don't know who this Sorry. Other one died. So, you know, I'm looking at
That's my sister. One of the videos.
Like you have a sister.
I couldn't spell. She couldn't spell.
You talking about?
Yep.